then I'm going to share my screen. Too many steps. Screen, share, and then our PowerPoint. All right, so let's see how this works. We are going to continue with our trig functions. Today, we're going to spend some time first looking at this unit circle to go back over that a little bit. And then we're going to look at finding trig functions of any angle, okay? Some of this we're going to use like our SOHCAHTOA stuff. And then towards the end, we're also going to use our unit circle. So this unit circle, I'm going to let you use it on any test or quiz or whatever. As you go through it, it has all the information. And let me pull it up and let's see. I'm going to stop sharing my screen with you people at home, and I'm going to share it from a different computer. And where's Zoom? I'm going to share my ladybug. All right, so that's what's on the screen there. It's a little bit tough to see up there because it's so far away, but you have this sheet in front of you. Okay, so let's just sort of review. And let me tell you what, let me take this down a little bit and see if I can, that's a little better. All right. You should be able to see what's going on. So the unit circle, what we talked about the other day, right? They create the unit circle because the radius, all right, the distance from here out to there is 1, okay? And then we went through the video that showed how they get that x and y is equal to, and if you notice there at the bottom left, it tells us that the x coordinate all the way around, that is the cosine of each one of those angles. And the y coordinate is the sine of each one of those angles, correct? So if we were looking right here at the 30-degree angle that is created, right? Okay, 30 degrees, it also has the radian equivalent, which is pi over 6, okay? And then we know, based on that, the cosine of that angle, 30 degrees, is equal to the x coordinate. So we can go all the way around this circle, and real quickly we can tell the cosine of each one of these angles. That's what this unit circle tells us. Square root of 3 over 2, square root of 2 over 2 is 45, 1/2 is 60 degrees, and then it goes to 0 for 90 degrees, and then, right, those numbers, it's the same 3 numbers or the same 4 numbers that keep repeating. As we go back around the other side, it's negative 1/2, negative square root over 2, negative square root of 3 over 2. All right. Now, one thing I want us to make sure that we notice is because of the coordinate axis, right? The coordinate axis is the middle of this, right? X coordinates are always negative in quadrant 2 and quadrant 3, right? So what we know is the cosine is negative for every angle that's in quadrant 2 or quadrant 3. What do we know about the y coordinate, which is the sine? We know that coordinates for the y coordinate are negative when it's below the x-axis, right? Which is quadrant 3 and 4. So we know any sine that's in for any angle from 180 to 360, we know that that is a negative answer, okay? And there is a little shortcut if we talk about, well, let's not even do that. Let's just concentrate on that right there. That's the easiest way to look at it, right? Quadrant 1, we know both the sine and cosine are positive. Quadrant 2, we know the cosine is negative, sine is positive. Quadrant 3, they're both negative. And then quadrant 4, they're both positive. Now, what I want to do from here today is I want to add to this is I want to add the tangents, okay? What do we know about tangent? Well, tangent is what? SOHCAHTOA is opposite over adjacent, which the opposite comes from the sine, right? So, and the cosine comes from the adjacent. So opposite or adjacent can also be stated that our tangent is going to be equal to sine over cosine. Right? The sine comes from the opposite, the cosine comes from the adjacent. Tangent is opposite over adjacent. All right? So if I want to know the tangent for each one of these spots, all I have to do is put the sine over the cosine, which is the y over the x. Now, what you'll notice in all of these in-between angles, it's real easy when it's 0 and 1. Let's start with 0, 90, 180, and 270. Let's write in the tangents of those. So out to the side, I would go ahead and write these in on your unit circle so you have it. All right. And I'm just going to write out here tangent equals, for this one, is sine over cosine, or y over x. 0 over 1 is equal to what? 0. So we know the tangent of 0 or tangent of 360 is equal to 0. All right, the tangent, and we'll just say this is 90, so we put a number there. You can fill in 0 right there. The tangent of 90 degrees is sine over cosine. Well, sine is 1, cosine is 0. 1 over 0. What's the problem with 1 over 0? Anyone? What happens when we have 0 in the denominator? It's undefined. So what we know is tangent at 90 degrees either does not exist or is undefined. All right. Then as we go over here, we've got tangent of 180 degrees is 0 over -1, which is 0. And then when we go down to 270, we're back to -1 over 0, which this is now also undefined. And I didn't spell that right, but you can on yours. Okay, so we've got 4 of the tangents labeled onto this now. And we just have to know the sine is the y coordinate, the cosine is the x coordinate. All right. Now, let's look at our 3 angles in the first quadrant, the 30, the 45, and the 60. When we're dealing with trigonometry, 0, 30, 60, or 0, 30, 45, 60, and 90-degree angles is where a lot of your time is spent. Okay? And so this unit circle comes in handy because it gives us a way to get those tangents, cosines, sines of those angles fairly quickly. All right, now, right here is going to be my tangent of 30 degrees, or pi over 6. Okay, now, I'm going to go write this down on this whiteboard, but tangent of 30 is going to be the sine over the cosine, or the y over the x. Well, what's y? 1/2. What's x? Square root of 3 over 2. Now we need to simplify that. Now, since both of those denominators are 2, they basically cancel with each other. So the 2 and the 2 cancel because they're both in the denominator of each part. So essentially I have 1 over the square root of 3. Now, a lot of the answers in WebAssign right now will allow you to put the square root in the denominator, which is fine. The way you're going to see this more often is, remember, we can't leave square root in the denominator of a fraction. So the way you're going to see it written is we have to rationalize, right? We talked about that. We've got to multiply the top and the bottom by the square root of 3. And then that leaves me the square root of 3 over. And then anytime you have a square root times itself, you end up with what you started with, which is 3. So this is what you're going to see as that, well, what that simplifies to. So we know, if I go back to this now, the tangent of 30 degrees is the square root of 3 over 3. Now, this is something we're going to sort of talk about later today, is reference angles, okay? Which means in each one of these quadrants, there's going to be an angle that acts very similar to the 30-degree angle, right? So let me go over here to quadrant 2, and which one of these has the same absolute value, if you would, just the square root of 3 over 2 as the x and the 1/2 is the y. Does everybody see that the 150 degrees has that same? So that means we're going to put the same y over the same x. So it's going to simplify to, so if I take the tangent of 150, that is also going to simplify the square root of 3 over 3. Now, we have to worry about the sign, right? We had positive 1/2 over negative square root of 3 over 2. A positive over a negative simplifies to a negative. So I know that the tangent of 150 is going to be negative square root of 3 over 3, right? So when we have coordinates that have opposite signs, my tangent and cotangent are going to be negative. So if we're just looking at tangent, that means tangent is going to be negative in what two quadrants? Obviously 2, and what's the other quadrant that has opposite signs in the ordered pair? 4, right? So we know tangent is going to be negative in 2 and 4, while it's positive in 3. So let's go down to quadrant 3. Which quadrant 3 is sort of the reference or has the same x and y absolute values? Well, 210. So we know the tangent of 210 degrees is going to be square root of 3 over 3, and they're both negative, so we end up with a positive square root of 3 over 3. And then what about the fourth quadrant? Which one of those? That's going to be 330, right? So the tangent of 330 degrees is square root of 3 over 3, and we know it's negative because we got a negative over a positive. All right, so when we talk about reference angles, that's kind of what we're talking about, because these numbers, the sine, the cosine, and the tangent, these results sort of repeat themselves as you go around the dial there. All right, now let's look at the 45. All right, so the tangent of 45 degrees, or what do we call that? Pi over 4. All right, is this. Now we don't even need to write this down. It's sine over cosine. Sine is square root of 2 over 2. Cosine is square root of 2 over 2. Well, what's the square root of 2 over 2 over the square root of 2 over 2 going to simplify to? 1, right? Anytime you have the same thing over itself, it reduces to 1. So we know the tangent of 45 degrees is 1. They're both positive, so we're positive. All right. What's sort of its reference angle, or what matches up, is the tangent of 135 degrees, right? We know tangent is negative in quadrant 2. It's going to have the same result, so we know that it's negative 1. Go down here, tangent of 225. We know it's going to be 1. It's a negative over a negative, so we know the resulting value is positive. And then down here, tangent of 315. We know it's 1. It's a negative over a positive, so we know it's going to be negative. So there we filled in the tangent off our unit circle. All right, now our last one are the ones that match up with 60 degrees. So we want to know the tangent of 60 degrees. We might be able to get by without writing this down, but let me go ahead and write it down. So we've got tangent of 60. We know is sine over cosine, or y over x. So we've got the square root of 3 over 2 over 1/2. Well, we know because the denominator is 2 in both of them, they cancel, and I'm left with the square root of 3 over 1, which is the square root of 3. So the tangent of 60 degrees is square root of 3. All right, now let's go over to quadrant 2. That's going to match up with the 120 degree angle. Tangent 120 degrees is square root of 3. And we know tangent is negative in quadrant 2. So that's a negative square root of 3. Down here in the bottom, tangent of what? That 240. We know it's square root of 3. It's negative over a negative. We know tangent is positive in quadrant 3. So there we go. And then the last one, the tangent of 300 degrees is square root of 3. And we know tangent is negative in quadrant 4. So now you have your unit circle that you can use that has the sine, cosine, and tangent of all those major angles all the way around the unit circle. All right. And here's what I know. If I have sine, cosine, tangent, sine, cosine, tangent, sine, cosine, tangent, and then I go to quadrant 4 and sine, cosine, tangent. In quadrant 1, they're all three positive, right? In quadrant 2, what do we have? The sine is positive, the cosine is negative, and the tangent is negative. In quadrant 3, sine is negative, cosine is negative, tangent is positive. And then in quadrant 4, sine is negative, cosine is positive, tangent is negative. All right? And if you are just worried about the positive and negative values of each of those, there is a little saying called all students take calculus. All students take calculus as you go around quadrants 1, 2, 3, and 4. What's that mean? All means they're all positive. Students, S, is what's positive. Students goes with sign, which is positive. T, take, all students take. That means the T or the tangent is positive. And the last one, calculus, the calculus or the cosine is positive. So that's one little mnemonic to remember where the positives are as you go around. All students take calculus. All right. So any questions on our filled out unit circle? All right. We're going to use that a little bit later. And now we're going to talk a little bit about finding sine, cosine, and tangent if it is not out of a unit circle. So I'm going to set that off to the side a little bit. Let's see. Let me pull up the PowerPoint. No, I'm not sharing that, so I need to stop my share. All right, and I'm going to share this screen now. I'll share the PowerPoint. All right, so this chart right here, this is very similar to what we were just talking about on the unit circle. Let me see if I can write on this. I'm sharing. Annotate. There we go. All right, so if you'll notice this chart right here, it says the sine of theta is equal to y over r, which goes back to where we were when we were talking at the first of the unit circle. The reason sine equals y and cosine equals x, if you remember, is because we let the r equal 1. So if it's a unit circle, that r becomes 1, and there we are, right back at sine of theta equals y, cosine of theta equals x. But if we have an angle on a coordinate axis where that uh, side of the angle is got a radius or a length greater than 1, okay, then we've got to put that radius back in there because we're going to look at some where we're using this to find the angle. All right. So we end up the sine of theta is y over r. Cosine of theta is x over r. All right. And then notice the tangent is still y over x. Cotangent, you just flip it, right? So we do need to realize, too, that the secant is the inverse of cosine. The cosecant is the inverse of sine, okay, which is from a couple of lessons ago, too, also. All right. So basically, right now, we're going to look at a few where we have a radius length or a length of that side greater than 1. So we're going to use another method other than the unit circle, and then we'll circle back to the unit circle at the end. All right. And we've already gone through that. Because the radius cannot be 0, it follows that sine and cosines are defined. There's nowhere where sine and cosine are undefined. Like tangent is undefined right at the top and the bottom at 90 and 270. And secant can be undefined. Secant and cosecant can be undefined because sine and cosine can be equal to 0. Once you flip over 0, it becomes undefined. So we'll get into that as we go on through. All right, so here's what we want to be able to do. All right, is we want to find the sine, cosine, and tangent of what this angle is based on what is drawn. Now, this is sort of going to go back to how we created that unit circle. In that, because that point is at negative 3, 4, all right, and we don't know what r is, we know the sine comes from the y, and because we don't have a unit circle, that r is a radius of length other than 1, we know that the sine is going to be equal to 4 over whatever that radius length is. Now, is there any way that we can figure out what that radius length is? Anybody have an idea of how we could find out what r is? Say that again.
I forgot. Basically, you're giving the what's it called? Just look at the graph. It's went all the way to -3. That's 3.
I think what you're trying to say is you can set it up like a right triangle and use, that's it. So Randy has told us from home that we can set it up like a right triangle, just like they did in that units circle video we watched. We know the y here is 4. We know the x is -3, or we don't put -3 there because the length of that triangle is actually 3, right? So now we can use Pythagorean's theorem. 3 squared plus 4 squared is equal to that radius squared. And so what do we have? 9 plus 25 equals r squared, and that is 36. Am I adding that right? Or is it 34? No, 9 squared plus 6. I'm skipping. We all know 4 squared is 16, not 25. That's 25 equals r squared, and then the square root of 25 is 5. All right. Always remember that one thing, if you hadn't ever been taught, that there's a couple of common right triangles. 3, 4, 5 is a right triangle. If you have 3 sides of a triangle that's 3, 4, 5, you know it's a right triangle. Okay. If you ever need to know if something is perfectly square, like if you were building a house and you want to know if the corner you've got built is square, you could measure 3 feet down one side and 4 feet down the other. And then when you measure the hypotenuse, it's got to be 5. If it is, then you know you've got it squared off. Okay, but anyway, there we go. So now we can go back to our SOHCAHTOA. SOHCAHTOA, and we know the sine is equal to, all right, now we're actually looking at like this would be theta, but when we're talking about these reference angles, because this angle and this angle here, right, we talked about this, they're coterminal. Coterminal angles have the same sine, cosine, and tangent. So whatever the sine, cosine, and tangent of this angle is, the cosine, cosine, and tangent of this angle is going to be the same. All right. So we know that sine is opposite over hypotenuse, so it's going to be 4 over 5. We know cosine is going to be adjacent over hypotenuse, 3 over 5. And then we know the tangent is the opposite over the adjacent, 4/3. Okay. So we know that the sine, cosine, and tangent of the angle, that's what they are. So that's how you're going to work through these problems. You're going to create your triangle, okay, and find your sine, cosine, and tangent. They're just going through the 5. Oh, now, the one thing I did mess up on is the sines, okay? I did forget that, so I've got my basics there. Make sure I did that right. Negative 3/5. Cosine is 3/5. Yeah, that's what I wrote down. Okay. That angle is in quadrant 2, right? So we know what's positive in quadrant 2. All students, sine. Sine is positive in quadrant 2, and we know the cosine and the tangent are negative in quadrant 2. So that's that. I sort of forgot about that. But remember, now you got to look at those angles and you got to look at what quadrant it's in as you look at that angle to tell us if it's a positive or negative sine, tangent, or cosine. All right. The base numbers stay the same. If you looked at the absolute value of everything, it wouldn't matter what quadrant. But because that is in quadrant 2, we know x values are negative in quadrant 2, which goes with sine. All right. And then we know cosine would be negative, and then tangent's going to be negative. All right. So any questions right there? Okay. Let me look. Let me see if I can pull up. Our WebAssign. I'll look at the assignments. All right. So what's next is going to be talking about reference angles. Okay. So next thing we're going to do is we're going to talk about how I'm going through and what angles in second quadrant match up to the angles in the first quadrant. And you can use that unit circle because now we know by looking at it, right? If you took the absolute value of everything, reference angles are going to have the same thing. We know that the 150 degrees is going to be the same as 30 degrees. They're sort of reference angles, but we're going to talk about here another way that we can actually figure that out. All right. And it's going to be just a matter of adding and subtracting 180s, and I believe we use 360. Okay. Yeah. Okay. So theta is an angle in standard position. Its reference angle is the acute angle with a little theta with an apostrophe. Okay. So this is what they're doing in here is when you see theta, that's the original angle. Theta with apostrophe is the reference angle. The reference angle is the 0, 30, 45, 60, or 90 that is the base for the value of the sine, cosine, and tangent. All right. All right, so here's the rules. You're going to have a rule for quadrant 2, a rule for quadrant 3, and a rule for quadrant 4. Quadrant 1, you don't need reference angles because those are the reference angles. So if your angle ends up in quadrant 2, which means it's between a 90 and 180 degree, to find the reference angle, you take 180 degrees minus theta, or minus that angle. Or if we're using radians, which you're going to be having to use radians more often in your assignment, it is pi minus whatever the angle is. So if this is a 150 degree angle, all right, to find the reference angle, I take 180 minus 150, and so my reference angle, my theta with apostrophe, is 30 degrees. Okay, does that make sense? Now, if I were doing it in radians, it would be pi minus the 150 degrees in radians is 5 pi over 6, which when you subtract, that's 1 pi or pi over 6. So the reference angle is pi over 6. Okay? So for angles in quadrant 2, you subtract it from 180 degrees. Now look at the next one. Reference angles in quadrant 3. So if your angle's in quadrant 3, we basically want to find out how far does it pass the 180 degrees. So you're going to flip it around. You're going to have the angle minus 180 degrees. And that will tell you what angle it matches up with in our first quadrant. Okay? So if this is a 230 degree angle, I'm going to say 230 minus 180, which is 50. So that's a 50 degree reference angle. Or it's going to be theta minus pi. Angle minus pi. Then for quadrant 4, right, this is an angle that goes all the way around. Okay, notice the reference angle is what's left before you get to 360. So to find the reference angle in quadrant 4, you subtract it from 360, or 2 pi. So quadrant 2, we say 180 or pi minus the angle. Quadrant 3, we say the angle minus 180 or pi. And then for quadrant 4, you say you subtract it from 360 or 2 pi. All right? So you're going to have problems like this right here. Okay? So they want, let me write this on this whiteboard. It'd be easier for me to, they want 300 degrees. They want 2.3. And they want negative 135 degrees. Okay? Now let me stop sharing that. And let me share again over here. All right, so they want the reference angles for these 3 right here. Okay, now let's look at 300 degrees. And I'm going to have to raise this back up so we can see what's going on. Okay, 300 degrees is the angle that is 300 would be about right here, somewhere right in here. Okay. So all they want to know is what's the reference angle? What's the theta apostrophe? So remember what we said. If it's in quadrant 4, we subtract it from 360 degrees, right? So 360, so that means there's 60 degrees left right here. So that means my reference angle is 60 degrees. Easy enough. All right. Now, 2.3. Notice this does not have a degree. So this is in radians. Now, you get Associated Radians always has a pi. Well, what they did is they went ahead and multiplied the pi in 3.14 times whatever, and we got it about 2.3. Okay, so where is 2.3 on our graph? Well, pi, we know, is 3.14, right? And pi over 2 is half of that, which is, where's the calculator? 3.14 divided by 2 is about 1.57. So we know that this is in quadrant 2, right? And to find angles in quadrant 2, we subtract it from 180 degrees or pi. So my reference angle is going to be pi minus 2.3. All right, which is going to be about 0.84. Okay, so that would be the reference angle. Okay, now when we're trying to find sine, cosine, and tangent by reference angles or things like that, you're not going to do a decimal like that, because then you got to have a calculator to find it. We do reference angles when we're talking about the 0, 30, 45, 60, 90, but this is officially a reference angle for that. That means whatever the sine of that is going to be the same as the sine of that one, except the sine may be different. Okay, so 0.84. And then the last one, all right, so right there, that reference angle was 0.84. Then this one, a negative 135 degrees is, negative means we're going this way. This is 90 to 180, so we know it's down here. All right. So really what we need to do here is we need to find out what the positive angle is, right? Because when we have this angle, it doesn't matter what the angle is, if it's the negative angle or the positive angle, or if it's a reference angle, the sine, cosine, and tangent are all going to have the same numbers. So first thing we need to do is how am I going to find this? Is I'm going to add 360 to that. If I add 360 to that, that's going to tell me what this angle is right here. Okay, so negative 135 plus 360 is 225, which now to find the reference angle to that, quadrant 3, we take the angle minus 180, which is what, 2045? So there, if I'm asking you about the reference angle, it is 45 degrees. All right, and then let me stop sharing here, and let's go back to sharing here. And you notice there they took it out to four degrees for that 0.84. We stopped at 4 degrees, 4 decimal places. All right, so any questions about finding reference angles? You just got to know which quadrant it's in. And that's what we just did. All right, so that chart right there, that's basically what we have on our unit circle, and I suggest using that unit circle rather than this chart. And let me see, I need to pull up our assignment so I can see example of what we're going to be web assignment. If you'll just give me a second to pull this up. All right, this is going to be assignment 4.4. And what I'm going to do now is I'm just going to pull up the assignment so we can sort of take a look at it and see what it's going to be asking. So let me share again. Where is that? That's what I want to share. Okay. So I'm just going to sort of go through the assignment quickly so we all have a good idea what's going to be on there. Which quadrant is cosine positive? We've talked about that. Is the value of cosine of 125 equal to the value of cosine of 55? That's just a reference angle question. All right, 180 minus 125, if that equals 55, then the numbers are right, but then you have to check the positive and negative, right? Determine the exact values of the 6 trig functions. So let me go over this one just to make sure that we have a good understanding of what we're going to be doing. All right, so I've got to share. Let me just share my screen. That way I don't have to. All right, so there's the problem. This is a problem that's coming right off your work. All right, it's 4, -3, and they want to know the sine, cosine, tangent. They want to know cosecant, secant, and cotangent. All right, and we know all students take calculus. Our cosine is going to be positive here, and our sine and tangent are going to be negative. Okay, well, if sine is negative, that means cosecant is negative. Cosine is positive, that means secant is positive, and if tangent's negative, we know cotangent is negative. Now, what we did was we complete this triangle, right? This is 4, this is 3, that means that's 5. So my sine, we're talking about this angle, my sine is going to be negative, opposite over hypotenuse, -3/5. The cosine is adjacent over hypotenuse, 4/5. Tangent is opposite over adjacent, 3/4, -3/4, right? Now for cosecant, secant, and cotangent, I've just got to inverse them. So this is 5/3, secant's inverse of cosine, so that's 5/4, and cotangent's inverse of tangent, that's 4/3. Okay? So that's what's going on with that problem. Nope, that's not what I want. Where are we at? Oh, wrong one. There we go. Another problem just like that, just at a different point. And you got to calculate, you got to use your Pythagorean theorem. Same thing, same thing. Same thing here, except they want you to draw it out. Okay, it gives you the point 9, 40. So that means you got to go over 9, up 40, and then draw your triangle and use the quadrant to get the signs right. Same thing there. More on what's positive and negative. State the quadrant when tangent is positive and cosecant is negative. Find the values of 6 triangle of theta given the constraint. So this time they give you the cosine. So what they've done is they've told you the adjacent and the hypotenuse. So then you've got to use Pythagorean theorem to find the they've given you the adjacent and the hypotenuse. You got to use Pythagorean theorems to find the opposite and then use your SOHCAHTOA. Tells you what quadrant it's in, so you know which ones are positive and negative. Find the value of 6 trig functions of theta with the given constraint. The constraint is between pi over 2 and 3 pi over 2. That means that the constraint just tells you what quadrant it's in. That is in, actually, it's in either quadrant 2 or 3. All right, which the sign, if the sign equals 0, all right, we know off our unit circle, when the sign is 0, that is at 180 degrees or pi. So we know the sign, we already know is 0. We can look on our unit circle. We know the cosine is -1. We know the tangent is 0. And then we can do the inverses. All right. Which means if it's 0 and you take the inverse, it becomes undefined. If it's undefined and you inverse it, it becomes 0. Evaluate the trig function at the angle. So secant of pi, we go to pi on our unit circle. Secant is the opposite of cosine. Cosine is -1. So that means when you flip that around and inverse it, the secant is -1. So that's what it's wanting you to do there. Okay, all that is off your. Then here's finding reference angles. All right, if theta is 205, which is in quadrant 3, that means we're going to take the number minus 180. There we go, there we go, there we go. Reference angle, reference angle. And then the last one, it says evaluate the sine, cosine, tangent of the angle without using a calculator. 330 degrees. Basically, you can pull it, all you got to do is pull it off your unit circle, 330 degrees. So that's sort of it. So unit circle is going to help you with these problems. And then remember all students take calculus, what's positive and negative. All right. Remember that sine, cosine, and tangent are inverses of cosecant, secant, and cotangent. Remember how to find your reference angles. So that should be it for just in time for your bathroom break. And then I'll activate the assignment. Let's see. I think I've stopped sharing screens. I need to somehow stop. No, that's not what I need. I need this. Stop.